Here we're asked to evaluate. I notice this d over dx here in front of my integral. That's telling me I should apply my second fundamental theorem of calculus. How that theorem gets applied to this problem, I start with this function on top of 2x squared minus 3x. I plug it into this secant squared of t in the place of t. So how that would look, it would be secant squared of 2x squared minus 3x. And now what we're going to do is we're going to multiply by the derivative of this function we just plugged in. The derivative of 2x squared minus 3x would be 4x minus 3. As we continue applying the theorem, we subtract. Now we basically repeat the same process, only take the bottom function of 7x, take that 7x, plug in the place of t. We get secant squared of 7x. And then we multiply onto that the derivative of the 7x we plugged in, which would be 7. And if we're pretty loose about simplifying here, this would be an acceptable evaluation for this problem. So another similar problem to the last one, we're applying the second fundamental theorem to evaluate this problem. We start with the 3x squared that we see up here. We plug that in the place of t for the function as it's defined here that we're applying this integral to. We get 1 over the square root of 1 plus t, which is now 3x squared when we plug in. On the end of this function, we tack on the derivative of 3x squared that we plugged in. That would be 6x. From that, we subtract. Now take sine of x down here, plug in for t. We've got 1 over square root of 1 plus sine of x. To this, we multiply on the derivative of that sine of x we just plugged in, which would be cosine of x. Now, if we simplify within reason, we probably should take these expressions here that we tacked on and maybe multiply on up to the top. Doing that, we would have 6x over the square root of 1 plus 3x squared minus cosine of x all over the square root of 1 plus the sine of x. For all intents and purposes here, that is reasonably simplified, so that's a reasonable evaluation. So we have some given information on this problem, and we're asked to use this given information to find a few values. The first value we're asked to find is f of 3. So to find f of 3, we got to think about what that means. This 3 here, based on how the function is defined up here, that 3 is replacing x. So anywhere I see an x over here, I need to substitute a 3 in its place. Now, when I substitute a 3 in the place of x, the only place I have that substitution is up here. So if this is going to be a 3, and this is a 3, then I already know that this particular piece is going to equal 0. So, does f of 3 equal 0 in this case? Not exactly, because we do have this minus 5 here. And if we want to actually solve for and figure out what f of 3 is, we should take that minus 5, we should consider it, add it over to the other side. So we plugged in 3 in the place of x, this part was 0, but now we're adding on 5, so we find that f of 3 equals 5. Next thing we want to figure out is f prime of 3. Now, to figure out f prime of 3, we need to find f prime of x. So, f of x is everything we see here plus 5. If we're going to find f prime of x, so let me write that out down here, we need to take the derivative of that function that is given as it's defined. So I see that I'm taking this derivative of this integral. That means I have to apply the second fundamental theorem. So if I apply the second fundamental theorem, I start by taking x, plugging in the place of t right here. I get the square root of x squared minus 8. Now as I think about what follows, I would multiply onto this the derivative of what I plugged in. So the derivative of x is 1. I would subtract. Now I take this bottom value of 3, plug in the place of t. I'd have 3 squared minus 8 under that root. And then I tack onto this the derivative of the number I plugged in, 3, which would be 0. So f prime of x equals all of this, and if I simplified it, all that would be left would be the square root of x squared minus 8. So if that's all that's left, knowing that I'm plugging 3 into this, it'd be 3 squared 9 minus 8, 1. I'm taking the square root of 1, which is simply 1. All right, the last thing we're going to do for this problem is we're going to evaluate f double prime of 3. If we're going to evaluate f double prime of 3, we're going to have to take the derivative of the first derivative to get the second derivative. So here's the first derivative. Let me rewrite that over here. F prime of x equals the square root of, it was x squared minus 8. So that means the same thing as x squared minus 8 raised to the 1/2. Finding the second derivative. Got to use a chain rule here to take this derivative. I would bring down 1/2, multiply by x squared minus 8. New power would be negative 1/2 because I took 1/2 subtracted 1. And then to complete the chain, I tack on the derivative of the inside. That would be 2x. If I do some simplifying here, I see a fraction being multiplied through here. I see this negative exponent. That's going to generate a fraction here when I simplify. Denominator of 2 is on the bottom. Negative exponent. And relocate this expression to the bottom, make that a positive power now. Everything else, this 1, this 2x, would remain on top. Now, these 2's we could divide out. And essentially what we're left with for our second derivative is x over the square root of x squared minus 8. So if I take 3 now and I plug in for these x's, I would have 3 over the square root of x squared minus 8, so that's 3 squared minus 8, or 9 minus 8, which is 1. Meaning f double prime of 3 here is just going to be 3.